Session 4. Posture and Body Movements Nov 27. Objectives. At the end of this presentation, you will be better able to identify postural risk factors for work-related disorders. Apply basic tools/instruments in analyzing posture to arrive at appropriate interventions to reduce risk of disorders. Building blocks for workplace ergonomics. Body positions, movement, and forces. Posture. Position of the body. Angular relationship between body parts. Alt. Importance of posture analysis. Determine stability of person in posture. Estimate loads on muscle and joints. Estimate fatigue and recovery times. Estimate forces exerted during posture. Hazard assessment. Why use neutral postures? Awkward posture leads to fatigue. Stress on muscles and joints is produced by working in extreme awkward postures, near extreme ranges of motion. Neutral versus non-neutral posture. Non-neutral posture, radial and ulnar deviation, flexion, extension. ASCII. Alt. Twisting about waist, lateral bending, back flexion, back extension. ASCII. Alt. Elbow flexion, elbow extension, shoulder flexion, shoulder extension, shoulder abduction and extension. ASCII. Alt. Extreme posture. Posture close to the end of the range of motion. Reduction of blood flow. ASCII. Alt. Postures allowing gravity to act about a joint. Create or increase loads on muscles and other tissues. Static loading for extended periods of time, a risk factor for WMSDS. ASCII. Alt. Methods to evaluate ergonomic stresses. Measuring method. Advantages. Disadvantages. Observation, checklist, job analysis. No equipment needed, nominal to ordinal measures, minimum time. Observer training, not possible to observe all aspects of work. Calculation. Minimum equipment, absolute measures. Requires simplifying assumptions, requires considerable knowledge. Instrumentation. Absolute measures. Requires equipment and intensive training. Psychophysical, comfort/discomfort rating. No equipment needed. Requires study of several workers doing the same job. Factors to consider when analyzing posture. Duration, frequency of posture. Type of posture. Effects on person maintaining posture. Discomfort, fatigue, pain. Methods of posture classification. Continuous classification. Actual angles measured. Real numbers. Reported as summary data. Mean, SD, range. Continuous posture classification. Thoracic bending, trunk inclination. ASCII. Alt. Trunk inclination by display type and size of computer. ASCII. Alt. Macro-postural classification. OVACO Working Postures Analysis System, OWAS. Description. OVACO Working Postures Analysis System, OWAS, Carhu, ETAL, 1977. A method for the evaluation of postural load during work based on a simple classification of work postures. Developed in Finland. Records posture, back, arms, legs. Records force. Records stage of work cycle. Seeks to identify postures where force exertion increases injury risk. Process of assessment. User makes a series of observations to record. Posture, 3-digit code. Back. Upper limbs. Lower limbs. Load, 1-digit code. Frequency of postures is counted usually by action categories and by task/jobs. Risk assessed in terms of frequency of postures by action categories compared to benchmarks. Steps in conducting OWAS. Observe work posture for task of interest, photograph or video, most common task or worst posture task, assign codes 4 digits, 3 digits for posture and 1 digit for load. Assign risk category, propose action, or determine frequency of each posture, in percentage, assign risk category, propose action. ASCII. Alt. Posture classification. ASCII. Alt. 2161, 2 back is bent, 1 both arms below shoulder level, 6 kneeling, 1 load less than 10 kilograms. Ask AI. Alt. Practice. Roughing out the wood block, brining out the basic contours of a piece. Ask AI. Alt. 4221, 4 bent and twisted, 2-1 arm at or above shoulder level, 2 standing on 2 straight legs, 1 load less than 10 kilograms. Ask AI. Alt. Action categories based on classification of posture. Ask AI. Alt. Downward arrow, interpretation, 2 corrective actions required in the near future. Ask AI. Alt. Action categories based on frequency of posture, example, you did 120 observations over 2 hours, back posture categories observed, 1. Straight, 16, 13%, 2. Bent, 20, 17%, 3. Twisted, 20, 17%, 4. Bent and twisted, 64, 53%. Ask AI. Alt. Arm posture categories observed, 1. Both arms below shoulder, 60, 50%, 2. 1 arm at or above shoulder, 60, 50%, 3. Both arms at or above shoulder, 0, 0%. Ask AI. Alt. Leg posture categories observed, 1. Sitting, 0, 2. Standing on 2 straight legs, 15, 60%, 3. Standing on 1 straight leg, 8, 32%, 4. Standing or squatting on 2 bent legs, 0, 5. Standing or squatting on 1 bent leg, 0, 6. Kneeling, 0, 7. Walking, 2, 8%. Ask AI. Alt. Pros and cons of OWAS. Pros. Simple and useful method for risk assessment. No specialized training. Validated method. Cons. Limited use for repetitive jobs, OWAS is not recommended for dynamic postural assessments. Limited use in assessing posture of upper limb, neck, shoulder, elbow, wrist. Does not include information on duration of postures. Does not differentiate right or left side. Micropostural classification. Ordinal. Flexion, 0 to 200. Flexion, 200. Rapid upper limb assessment, RULA, method. McAdamney, L. and Corlett, E. N. 1993, Applied Ergonomics, 24, 2, 91-9. RULA is a quick survey method for use in ergonomic investigations of workplaces where MSDS are reported. RULA is a screening tool that assesses biomechanical and postural loading on the whole body. RULA focuses on the neck, trunk, and upper limbs, and is ideal for sedentary workers, e.g. computer workplaces. RULA has been validated on groups of computer users and sewing machine operators. RULA is quick and easy to complete. RULA scores indicate the level of intervention required to reduce MSD risks. RULA complements other ergonomic methods. RULA assesses postural loading at a specific moment in the work cycle. Assess the highest risk posture being adopted. Select appropriate stage of work cycle for assessment. Highest risk posture for analysis. Longest held. Worst posture. Compare Grand RULA score to action level list to determine risks. Review scores for any undesirable postural deviations that need correction. Review possibilities to improve posture. If changes made, evaluate by RULA. Final score. 1 or 2 equals acceptable. 3 or 4 equals investigate further. 5 or 6 investigate further and change soon. 7 investigate and change immediately. Ask AI. Alt. Ergo-plus.com. Ask AI. Alt. Practice, office worker using computer. Ask AI. Alt. A. Arm and wrist analysis. Step 1, locate upper arm position equals to, approximately 20 degrees, plus 1, upper arm is abducted, minus 1, arm is supported and / or person is leaning, equals to. Ask AI. Alt. Step 2, locate lower arm position, 1, approximately 90 degrees. Ask AI. Alt. Step 3, locate wrist position, 1, 0 degrees. ASCII. Alt. Scores. ASCII. Alt. All steps for A. ASCII. Alt. B. Neck, trunk, and leg analysis. Head and neck posture at computer workstation. Ear-eye line. Tragus to outer canthus of eye. Reed's line. Outer canthus of eye and center of external auditory meatus. Frankfurt line, plane. Inferior margin of the orbit and the upper margin of external auditory meatus. ASCII. Alt. Trunk. ASCII. Alt. Legs. ASCII. Alt. Step 9, locate neck position, 3, 20 plus degrees. ASCII. Alt. Step 10, locate trunk position, 3, 20 plus degrees. ASCII. Alt. Exercise, ceramics dinnerware manufacturing. ASCII. Alt. Types of measurements. Postural analysis checklist. Rapid upper limb assessment. OWAS, OVACO Working Postures Analysis System. Video analysis. Facilitate job analyses. Assess risk factors for work-related musculoskeletal disorders. Frame analysis. Know who, what, how long to record. Key points. Posture analysis can be a tool for hazard assessment. Prioritize conditions that need to be addressed to improve posture. Posture analysis can be a tool to assess improvement in the workplace. Monitor improvement in posture as indicator of effectiveness of interventions.